Hello, my name's Anteo Jafari, part of Team 14575 Capital Bots. Today I'm here to talk about stress testing for FTC. Stress testing is a really good skill to have learned in Fusion 360 as it allows you to see whether your parts are able to withstand certain amount of force. It allows you to do testing and see if your parts will break before they actually break. So you get to see things through CAD before you run into trouble on the playing field. So we're going to be using a 3-hole channel for our demonstration, though you can be using any custom made part, really any part stress testing will work. So first thing we're going to do is um, once we've imported our part, we're going to go into where it says design, we're going to click simulation, and you can close out this left column if you'd like. So our simulation tab is opened, and here we have this new study window. We're going to click static stress. This is the basic stress testing, and that's what you're going to normally be using for FTC. Create study, and here we are, fully set up in our simulation workspace. So you can see it's different than what it looks like on the create design workspace. So in your left-hand column, you see info about your part, study materials, load. A lot of this stuff you don't really have to worry about, but just know it's there, and with more advanced parts, you may need to do some manipulating with these settings. But for what we're doing right now, first thing you're going to do is hit structural constraint, just this top piece. What this does is it creates, basically, it tells Fusion 360 this is the spot where my piece is connected and it's not moving. So it's going to stay still there, basically. You're constraining it from being bent within the simulation. So we're going to click this face. That's going to be my constraint. And you want all axes to be selected. You're going to hit OK. And as you can see, a little lock is above this face, showing that it's been constrained. So once we have our constraint, we're going to be putting the load on the part, basically the weight. So we're going to go to the opposite face here, and I'm going to click load right here, structural loads, this top square. I'm going to click on it, and I'm going to select this face. Then I'm going to enter the amount of newtons I want being put onto this face. So when you're actually trying to test for parts that you're using, you're going to want to calculate the weight and the force that's going to be being put on this the particular face you've selected. But for this example, we're just going to assume 50 newtons is what is being exerted on this face. So we're going to click OK, and you see we have the blue arrow now that appears, showing that this is where the force is being applied throughout this entire face, on the corners and in the middle throughout. Alright, so now we have our constraint on this side, and we have our force being pushed on this side. So once this force is executed, what is this part going to look like? Is it going to hold up, or is it going to bend, or even break? So let's see. We're going to go to solve right here. You're going to click solve study 1. This is study 1. So it's going to take a little bit. With faster computers, it'll be pretty fast. With slower computers, it may take a little bit of time, but you just have to be patient and wait for a bit. Alright, so here we can see it says status is complete, so we can go ahead, close this window, and now we have the results of our simulation. So first thing we see to the right is kind of our key. This shows us what's going on in terms of which color represents the amount of stress. So as you can see, blue is less stress in certain areas, and then as we move into green, yellow, and red, that shows where the most stress is put on these parts and where they're at most risk of breaking. So first thing I can tell is with this force, if it's going to break, if it's right here, this is where a lot of stress is being exerted on the part. So what this tells me is um, there's a high risk of this part bending and it won't be able to last. Another really important thing is, as you can see, there's an outline of the original part, and we can see how the part bent. So our U channel actually bent, and that tells you that you need to put a little bit more support somewhere in between the channel, either like a quad block or a beam, so you have some more strength to be able to withstand that heavy load. So that is Fusion 360 stress testing for you. As you can see, it really gave us insight on whether this U channel would be able to hold the load, and we were able to conclude that no, it cannot, and we needed to add either quad block beam, some sort of structural support on the inside of the channel. This is why stress testing is so important, because it really gives us good insight on what parts are capable of doing. Thank you for watching.